Welcome to the Insightful Professor. In today's presentation, we'll be talking about writing your own classes using Java. Now, we start off by taking a quick look at something we're familiar with, having been introduced to Java as a programming language, but not so much from an object-oriented perspective. Java, like many programming languages, has built-in or primitive data types. And these data types are listed here. We have various forms of integer. We have something called char, which represents a single character. And we also have double and float for floating point numbers, different degrees of precision or accuracy, as well as Boolean. So those are our fundamental building blocks. But it turns out that we can do much more than work with just these primitive or built-in data types. And that's the point of this video. Now, when we declare a variable using any of the primitive data types, we simply specify the data type, such as int, and the identifier, which serves as the variable. Now, what happens here is that a block of storage is allocated. The quantity of storage allocated is determined by the data type. In the case of a byte, we're looking at 8 bits, short 16 bits, and int 32 bits, and so on for these various data types. So it's a fixed amount of storage when we pick a particular data type, and the value that is assigned to that variable is stored within that memory, within that storage location. So here, as we declare how many as of type int, some block of storage large enough to accommodate an integer, which in the case of Java will be 32 bits as a binary value. That will be allocated, and then when we refer to how many, we'll be making direct access to this storage area and manipulating or accessing the content of the storage area, the actual value that's stored there. So if we continue and look at this, we can say, well, how many, the name of this variable, is assigned 999. That will cause a value of 999 to be placed within that memory area. So we're directly operating on the memory area that's associated with that particular identifier. Pretty straightforward. That's the way it works in other programming languages as well. However, when we work with objects, we are not using the identifier to directly refer to the storage area that contains the object. What we're doing is associating an identifier with a block of storage that makes a reference or points to, kind of contains the address or the location of where that object resides. Then we follow that reference and access the storage, kind of indirectly. So the idea is when you create a variable of some class type, what you're actually doing is creating a reference variable. So the nature of the data and the operations, incorrectly spelled here, for an object depend on the kind of object that we're dealing with. We've worked with the scanner class and created a scanner object that we've associated with something like the keyboard. And this allows us to retrieve a stream of input data entered by the user via the keyboard, and we can gain access to that. We've also created objects of the string class, where we have these character strings that store a sequence of characters, and we've been able to work with that collection of characters or manipulate individual characters within the string. But again, in either case, we've created a reference variable to refer to the scanner object that was instantiated, or to refer to the string object that was instantiated. But we did not directly operate upon the objects themselves. It was kind of indirectly by following this pointer or this reference. It's a very important concept because it's a very different way of thinking than working with primitive or built-in data types. Now, as we talk about objects and look at their characteristics, 2 points come to our discussion. One would be with objects we can store data. The pieces of data that are stored are sometimes referred to as fields or attributes, or sometimes we call them member variables or instance variables. Regardless of what name we associate with them, we have some kind of identifier within the object that can refer to or provide access to a chunk of storage of some particular data type, such as one of the primitive data types that we've mentioned. Objects can also perform operations. When we talk about the operations that can be performed, what we're referring to here would be something that is collectively referred to as the behavior of the object. And the behavior of the object is implemented through what are called methods. And these methods are also sometimes called functions, because typically they are implemented as functions. So we have the concept of member variables, fields, or attributes to hold data within an object. And we also have the concept of member methods or member functions within an object that allow us to operate on the data. And those functions then exhibit the behavior of the object. So collectively, the combination of the data components or the data elements and the code components, the methods, these are referred to as members of the class and hence members of the object. And we refer to these then specifically as member fields and member methods. Well, as much fun and as exciting as it is to learn the terminology, you're probably wondering or asking yourself the question that most people ask, and that is, where do objects come from? This is what we'll focus on in this particular presentation. We'll talk about defining a class. It's actually the class that defines what an object will look like. So the class can be thought of as kind of a blueprint from which objects are then created or instantiated. So when we talked about scanner and print writer and string, those were classes that were part of what's called the Java API, the Application Programming Interface. They are automatically available to us. But we have the ability to extend Java as a programming language or programming environment and define our own classes. These are sometimes referred to as user-defined classes. And this is really where the power of object-oriented programming comes to the surface. So a class is some kind of code that we will write that describes a particular type of object. In fact, as I said, it's kind of a blueprint for defining an object. So it actually defines a whole group of objects, hence a class of objects. It specifies both the data that an object can hold, those fields that we talked about, as well as the actions, the behavior that the object can exhibit, the methods for the object. So we describe both the data and the behavior when we define a class. So a class, as we said, could be thought of as kind of a blueprint that is then used to bring an object into existence. It kind of tells the Java virtual machine, the Java runtime environment, how to make one of these things when the need arises. So when a program is running, it uses the class to create as many objects of that particular class or type as would be needed. So in some of the programs that we've worked with in the past, we may have had more than one instance of a scanner object. We may have used the scanner object to receive input from the keyboard, interactively entered by the user, and at the same time we have another scanner object created to read input from a text file. So again, we can have more than one instance of a class, multiple objects of the same class instantiated and operational within a program. And that's pretty exciting. So the creation of an object is referred to as instantiating the object, or object instantiation, because we're making an instance of the class. That effectively is what an object is. So an object is accessed through a reference variable. When we instantiate an object, what happens is the reference variable gets populated to hold the address or the location or a pointer or the reference to where that object resides somewhere in memory in the runtime environment. Now, to access an object, we say a reference variable holds effectively the location of the object wherever it resides in memory. So a reference variable is the mechanism through which we gain access to the object to access its members, whether they be member variables or whether they be methods to operate on the object. And by the way, a term that's often used when we invoke a method. We're said to be sending a message to the object and causing it to receive some kind of signal, and then it responds to that. So two objects cannot occupy the same memory location, and again, another spelling error, location at the same time. So given some address in memory, there will be only one object residing at that address at any point in time. So when we place a value, which is a location, into a reference variable, it is pointing to exactly one object. So to create an object, here's what we'll do. We first declare a reference variable of the class, the object type that will be instantiated. And again, this will ultimately, when we instantiate the object, hold the location or the address of where that object resides. But we need to create this reference variable first. Then we can actually instantiate the object, cause memory to be allocated, and its instance variables initialized to some values. And at the same time, we'll take the address where this thing came into existence and put that address into the reference variable. So then we can subsequently use the reference variable to access the object. So after we complete this, the object is available and ready to be used. So again, an object is an instance of some class, and a class, once again, describes how the object will be created, what it will look like. Hence, it's a blueprint of the object. And it doesn't matter, by the way, whether we're working with classes and creating objects from the Java API or whether they're user-defined. The concepts that we just described apply to both types of classes and subsequently the objects that are instantiated. So let's draw a little sketch here and say what this looks like. Okay, what we have is, in this particular example, we're looking at scanner. Scanner being the name of a class. And what we're saying is keyboard will be the reference variable. So we'll then use this to refer to a scanner object that we instantiate. How do we instantiate the object? Well, we use the new operator. The new operator in Java allows us to kind of cause a constructor to be executed. And here's a new concept, the notion of a constructor. When we work with primitive or built-in data types, there's no such thing as a constructor. But when we're dealing with classes, notice the name of this function here is exactly the same as the name of the class. This particular function is called the constructor. It will cause an instance of this class to come into existence or be constructed. The way it is invoked is by using the new operator and saying, let's make a new one of these things, whatever it is, in this case, scanner. So this will invoke the constructor. Within the parentheses here, what we have is an argument that's passed to the constructor. As we talk about constructors and classes in some detail, we'll see that there are different types of constructors that can be created. By default, if we don't explicitly create our own constructor, we have one that will not accept any arguments, what is cleverly called a no-arg or no-argument constructor. No arguments are passed to it. But in this particular case, this constructor for scanner is expecting one object. And the object here is called system.in, which is effectively an alias for the keyboard. So this argument is passed to the constructor, and the constructor is invoked by using the new operator. The result of this activity will cause the object to be instantiated somewhere in memory. Memory is allocated for the object, and any instance variables or fields contained within the object are allocated and initialized. And then wherever that is in memory, the address is put back here into keyboard, and then we're good to go. We can just use keyboard to qualify references to the methods for this particular object that got created. And that's something you should be quite familiar with already. Having worked with scanner and print writer and string and invoked the methods, the concept is not new to you. This is really a refresher. Hopefully you're quite comfortable with this. So here's the idea. This variable called keyboard is a reference variable. So it simply has a block of memory that can hold a reference or the address or the location of wherever the object is in memory. The object got allocated somewhere in memory based upon new invoking the constructor for scanner. The object got created, and this variable here is actually a reference variable that points to or references that object somewhere in memory. So that's a little picture to kind of put it together. Here's another example where we're looking at print writer, and as we invoke the print writer constructor, again by using new to say let's create a new instance of this thing, and print writer is the constructor, we're passing it the name of some file, a text file called numbers.txt, and again the same concept applies. So again, both of these should be something that you're quite familiar with from your experience learning Java to begin with. Here's another example where we're using the random class to generate a random number. So what we're doing is invoking random, and notice what's interesting about this guy is random is invoked here, or its constructor is invoked without any arguments. So this is a no arg or no argument constructor. And we're simply invoking it, and some value is passed back, which is a random number generated by this object, and then we can then use that in various operations. But again, notice it's the same concept. Rand is of type random, which means it's actually a reference variable and contains the address or a reference to the object that got instantiated somewhere in memory. So with object instantiation, we saw that there are many classes provided by the Java API. And in some cases, in fact, in most cases, you'll have to do an import, right? Use the import statement to make scanner available. Import java.util.scanner. Then that makes that class available, and you can create objects on it. And again, the new operator is actually what causes the constructor to kind of kick in and actually instantiate the object. The address is returned from the new operator and placed within the object variable. So let's put this all together with a little demo. We've got a program out there called objectdemo.java. I'll go into my virtual machine and I'll show you how this works using the Eclipse IDE. Okay, so here we are with the Eclipse IDE already running. I'm using a workspace that's been allocated, and I'm just going to review a couple of concepts in utilizing this IDE that are kind of important. So here, I'm going to start off by going to the File menu, selecting the New option, and I'm going to create a new Java project. And the Java project I'm going to call is Introduction to Classes. So as I create the Java project, I give it a name. I take the setting here for the Java runtime environment, the JRE, and simply click Finish. And that will create this first object for me. So the Java project is created. Now what I want to do is I want to put something within the source. Rather than simply create a class and put it into this source, that would go into what's called the default package. I don't want to use the default package here, so what I'm going to do is I'm going to go ahead and create a new package. So I go File, New, and Package. And I'm simply going to call this Class Package. The package is going to be a way of collecting Java code from different classes that may interact with one another. This actually corresponds to a location within the operating system. There are some benefits to using packages that we'll talk about a little bit later, but I just wanted to show you how to create the package. Now with the package, I'm now going to create a class. And I can go ahead over here and say File, New, and Class. Alternatively, there's a little icon here which says New Java Class. So we can do it from here as well. I click on this, and I'm going to create a new class, and the class that I want to create is the one that I had mentioned to you, Object Demo. And this is going to be an application. What's the difference between an application and a class? Well, every Java program effectively is a class, but you can have classes that are not directly executable, but effectively define a data type, hence define what objects can look like when you create them. If we want to make something that is an executable block of code, what we need to do is to include a main method. So as we were writing Java applications early on, what we were looking at was the idea of creating an application where we could actually kind of fire it up or run that particular class by invoking it and causing the code in the main method to fire up or execute. So this guy here called Object Demo is a class, but it has a main method. Therefore, this is what's called a Java application. I fire that up, and the template code that's given to me has public static void main. That's where the action will begin. Okay? When we start to write our own classes that are not going to be applications, we're going to do things a little bit differently. So now, this is where the code is going to go. And I've got the code in another file, and this file will be available on the website if you want to grab it. But let me go ahead and grab this code myself. Whoops. And I'm going to put this into my program here that was created. I'm going to take my import statements, and I'm going to put those up here. And by the way, I should point out what happened when I created the package. Notice it says package, class package. So it tells me that this piece of code is within the package. That's going to be very important when we start looking at classes in detail. But keep in mind that I created my own package other than using the default package. Okay. Now let's get the rest of the code. So here's public class object demo. I'll just grab all of this, and I'll come in here and just replace this. Okay, and I'll go back and just get rid of that for the moment. So what does this guy do? This guy is really the type of program you might have written in the first Java programming course or in some of your first Java programs. What you see is I'm bringing scanner in through an import. That's making the scanner class available to this application. I'm bringing random in. I'm doing Java I/O, and everything within that, that library is being brought in. So what I have here is I have my class where I'm creating some variables of primitive data types, in this case integer, and then here's where I'm instantiating a scanner object, exactly what we looked at previously. And here's where I'm creating a random object, and I have my reference variable called rand, and then a print writer object, and so on. Okay, so all of this basically just compiling the examples that we looked at in the presentation. So all we're doing in each case is instantiating objects. We're just invoking the constructor for classes that are part of the Java API. So then what do? We go through a little loop. We get a random number, put it into the file, random number, put it into the file, and we do this for so many times based upon how many times the user specifies for this to happen. So let's go ahead and fire this up. And it says, how many random numbers should I write? Well, let's go all the way with 5. We'll live it up. And it says it's done. Okay, so there should be a file that's created called numbers.txt. Okay, that file is available over in the Package Explorer. If you don't see it, what you can do is use the right click with the mouse to bring up the pop-up menu and click on Refresh. And when you do refresh, this file should be shown here. So it's within this workspace that I was dealing with. Just to show you where that is, I open up Windows Explorer, and with the File Explorer, what we have is in the location where I have Introduction to Classes, sure enough, here's numbers.tet. So let's take a look at what's in this file. I'll open it up, and here are the random numbers that were put out. 1, 2, 3, 4, 5 numbers, exactly what I requested. Okay, so that's the idea of how this works. And again, that should be pretty much review to you, or review for you from previous experience working with Java. Now we're going to get into the exciting part where we're going to build our own classes. So let me put this on hold and go back to my presentation and pick up where I left off. So again, let's make a clarification or distinction here between an application and a class. Every Java application has a method called main, and this specifies the starting point of execution for the application. So an object-oriented program consists of objects that effectively interact with one another. And that's what we were doing within our application. We were writing objects or creating objects, and they may have been directly interacting with one another, or we may have been interacting with them. So that's what object-oriented programming is all about. So an object-oriented program then will have objects which have been instantiated from some class, and then we go ahead and work with those objects and have them interact by sending messages to one another to perform operations. Notice that the objects may contain primitive variables, but there are going to be some other neat things we can see, that objects may contain other objects. So let's get on to it, because I'm sure you're excited to see how all of this comes together. So a class, as we said, is a blueprint. So somebody wrote PrintWriter, wrote random, and wrote string and scanner and all of these other classes that are part of the API for us. And all we're doing is using the code that they wrote to define objects which are instances of those classes. So what we're going to do is define our own classes and recognize that as we do that, the class is a generalized description of something. And an object will be one specific instance or individual occurrence of whatever that something is. So if we talk about a student at some school, some college, some university, some high school, wherever, every student has a name. Every student has a date of birth, has an address, may have some major area that they are going to be, say, concentrating their studies in. And as they do that, what we see is, doesn't matter which student we're talking about, these are the general characteristics of all students. But when I create an instance of a particular student, what I'll see is one student will have a name that may be different from the name of another student. One student may have a date of birth that's different from another student. And likewise, address and major could be different. But the point is, the general characteristics or properties that every student has, we've summarized those here. The actual values of those properties for each individual student may vary. So the class defines that general blueprint. What will be the general characteristics of every instance? So when you work with a computer application to process data for students, you are going to need some way of representing information or data about one student, about another student, about yet another student, and somehow keeping that separate. So you'll need variables to refer to data for one student, variable for data for another student, and so forth. And that's where the reference variables come in. But as we note down here, it's the commonality that defines what the class definition or declaration is all about. And then we're going to actually create instances of the object, and within that we'll have variables or members or fields for each object that's instantiated. Very important distinction. When we talk about application in class, every application has a main method, and that's where execution occurs. But when you define a class, which is not an application, there will be no main method. Therefore, the class itself is not executable. So if I create a class called student and do not put a main method in there, I cannot compile and run it. I can compile it because it has code within it, but I cannot directly run it. I need some kind of a driver mechanism to invoke the methods within that class and hence within the objects that are instantiated. And that's going to be something we'll clarify as we go along here. So when we talk about objects, we're going to be talking about the structure, and the structure is going to refer to the composition of the attributes or the data within the object and defined generally within the class. And we'll start off by looking at something called a rectangle. Okay, and let's get right into that. We're going to take a look at rectangle and say, well, what kind of stuff would I want to store to describe a rectangle? If we think about a rectangle, it's defined as a quadrilateral, four sides, but it really has two dimensions. Two of the sides are referred to as the length, and two might be referred to as the width, because the two sides that are designated as being of length are the same distance or same measure, and likewise for the two that are width. So we basically say there are two dimensions that characterize this four-sided object. These dimensions then will become the fields or the attributes for our class that we're going to call rectangle, because every rectangle will have a length and a width. When we instantiate a rectangle object, then we'll actually assign values to the length for that particular rectangle that we're representing, and to the width for that particular rectangle that we're representing. Now, in addition to these variables that define, say, characteristics or data values, we're going to be able to do things with rectangles. Go back to some geometry course that you took, and what kind of things did you do with rectangles? You perhaps computed the area of a rectangle. You perhaps computed the perimeter of a rectangle. So that's one of the things that we'll do as we start to define the methods or the behavior or the operations that a rectangle object will be able to support. So the methods for the rectangle will be things like setting the length and setting the width. These two methods here are called setters. Not a very clever name, but they're also called mutators because they can change the value of the attributes. So we tend to refer to these as setters and preface the name with what kind of a method it is, a set method. We will set the value of the length attribute. We will set the value of the width attribute. So the setters or the mutators typically are named set and then the name of the attribute or field whose value will be affected when these are invoked. Likewise, we have member variables of length and width that we can set, but we might want to look at those. We might want to inspect their current values. So to do that, we would get their values. And not surprisingly, these methods are referred to as getters, or sometimes called accessor methods, or sometimes called inspector methods, or inspect methods, because we're just examining the values. So we've got get the length, get the width, and then the other one is a computation that's being performed to compute the area, and we're deriving that from the length and the width. What the exact formula is, don't know, don't need to know, okay? If you're using the get area will do whatever it's supposed to do and produce the computation of the area and return it to you. Now, if you're writing the class, obviously you have to know what algorithm to employ to compute the area. But if you're using it, you don't need to know how that was computed, because you're just saying, get me the area, whatever it is, and it will be computed and returned to you. So we have the setters, or mutator methods. And then we have the getters or accessor methods, also perhaps called inspector methods, because we can expect or examine the value. Now, when we go to write the code, this is where it gets kind of interesting. When we created our applications, we always created a class, public, class, whatever. The public is what's called an access specifier or an access modifier or a visibility modifier. It says something about how that particular thing can be viewed or whether it can be viewed from outside of the class. So the user of the class, what we want is they should not be allowed to directly access the fields. That is, they shouldn't be able to go into the rectangle object and say, hey, I'm going to change the length, or I'm going to look at the length directly. But we want to have what is called controlled access. We control the access by creating these setters and getters. And it's only through the setters and getters that users of the class and subsequently of the objects that have been instantiated from the class are then permitted to interact with the attributes. They cannot directly touch them. To ensure that the attributes are safe and cannot be directly touched, but must be manipulated or accessed only through the code defined in the setters and getters, we use an access specifier or access modifier called private. We declare the member variables as being private, which means that even though you can instantiate the object, you can't go into the object yourself and touch those things that are private. You don't even know they exist. But those things that are public are directly accessible to you. So what we'll do is when we create the member methods, the setters and the getters, we'll make those public, but we'll make the attributes or the fields private. This is what is called controlled access. Those things that are public are available to users to interact with instances of the object. They define what is called the interface to the object. Okay, that's a lot to swallow. So let's see if we can kind of piece this together by going ahead and getting ready to write some code. Take a look at a couple more slides and then we'll go and give this a try. So writing the code for the class. Here's again the public versus the private we talked about. And each method will be implemented with an access specifier, and typically the methods are going to have public visibility or public access specifier. And those that are public are accessible to us from code outside the object. They define, again, what is referred to as the interface to the object. So let's piece it together here. We'll say public, there's our access specifier. Then the return type. We've already talked about methods in previous opportunities to work with Java. So this is not new to us. And then we have the method name and then the parameter list. So we're defining what the parameters would look like. We're going to have a single parameter here called len, and it's going to be of type double. Okay, there's an observation that we make here that we're not using the word static, which is what we've used in working with methods up to this point, because this is actually part of a class, not an application. So this is going to be a little bit different. We'll talk about that in a bit more detail later on. Okay, but just notice the word static is not present here. So it's not public static void set length. It's public void set length, the name of it, and then within parentheses, the parameter. Okay, so here's what the code would look like. We'll put some documentation up here. And notice again, we're using a documentation comment, a Java doc comment, and we've got the param tag indicating len is the name of the parameter and a brief description of what it is, and also a brief description of the method itself. And all it's really doing is taking what is ever passed as input, whatever's passed as an argument, and taking that and assigning it to the length member variable. We are not permitted to do this directly ourselves because remember that length member variable was defined as private. So we're making this part of the interface to give us controlled access. So whatever you give me, then I will assign it to this. Now, this really doesn't show the benefit of the controlled access. But suppose we were saying you're going to give me the length of a rectangle, and then I'm going to put the length into the length member variable. What restrictions are there on the length and the width? Think about the possible values that are allowed and the possible values that would not be allowed for a length and a width, as we describe, say, a polygon or a geometric object such as a rectangle. Think about that for a moment. What would not be good? What would not make sense? Negative numbers would not make sense, right? We would not want a negative length or a negative width. So therefore, if this code was a little bit more complex, we would actually see the real benefit of the controlled access. Here, it's just taking whatever double is passed to it and assigning it. So even if you gave me a negative number, I would assign it to the length, which is not good. So therefore, what would happen ideally is if you gave me a number, I would first check it. A conditional statement, such as an if statement. And if the value is negative, I don't do this, but I throw an exception to signal to you, hey, that's not a good value. I can't use that. But if it is acceptable, then I'll consume it and assign it to the member variable of length. So that's where the controlled access would be much more beneficial in having this method. And we can see the idea of how it would work. So there are two files, rectangle1.java and lengthdemo.java. Let's go into my IDE once again, and we'll take a look at these in action. We'll actually build this and show you how this works. Okay, I'm going to just close out this object-demo.java file. And what I'm going to do is I'm going to create a new class. I'm working in the same package. I'm going to create a new class, and the class is going to be called rectangle1. I'm not going to check public static void main. I don't want a main method. I'm not building an application, I'm building a class. So there will be no main method, but it will be a public class. So I simply click finish, and notice how the skeleton code was created. Again, it's in the same package, and the name of the class is rectangle, but notice there's no public static void main. There's no main method. It's not an application. Again, I've got the code, so let me go and grab this. And I'll just take this part here, which says this is our first pass at creating a rectangle class. It's far from complete, but it's going to get us started as to how the classes are created. And then let me grab the rest of that code. Okay, and here we are. So now, what does this do? It's defining the class as rectangle. These are two member variables. These are both say fields or member variables, length and width, and they're both of type double and they're both private. So if I were to create a rectangle1 object, instantiate rectangle1 class, create an object, I could not directly refer to length and width. But what I've done is I've created the setLength method, and it's going to take whatever is passed and store it into the length member variable. So I can compile this, and I can compile this by doing Control-S from the keyboard. It saves it and compiles it. So that's great, except how do we use it? Well, we use it similar to the way that we use things like a scanner and print writer and so forth. We're going to have to instantiate objects of this class within an application. So let me go ahead and create an application. The application that I'm going to create is the one that I mentioned to you called length demo. And just bear with me for a moment as I grab that code. And I'll just grab this code, and then I'll go and say here I'm going to create another class. And this one is called length demo. And this one, because it's an application, will have a main method. So make sure you click public static void main here. So now we've got all this good stuff. Let me take the code that I copied and I'll piece it in here. We're going to start off by a brief description. Put that up here. Then I've got public class length demo, and notice this guy does have public static void main because this is an application. Now the neat part comes up here. Drop this in here, and just bear with me. I'll get rid of this other stuff that we don't want. Yeah, I think I was too enthusiastic there. Let's put one more back. There we go. And that should do it. Right? So there's my class, and there's the main. Now let's look at what the main is doing. The main says it's going to create a rectangle object. Technically, it's a rectangle1 object, and assign it the address of where it gets created to the box reference variable. So I say rectangle1, there's the class, which is this guy here that I had created a moment ago. And then what I've got is box is the reference variable. I use new and invoke a constructor. I did not explicitly declare a constructor. So what happens is Java will automatically create a no arg or no argument constructor for you. And that's what's happening here. Notice there are no arguments passed. It's just parentheses. So that gets created for us automatically. All that's going to do when it fires up will be to instantiate the object of rectangle and then take its instance variables, or say its member variables, and populate them with whatever the default value is for their data type. So it'll be 0.0 for length, 0.0 for width. That's what Java does when you have the variables of a primitive type and they get initialized. Okay, then I say now I'm sending the value of 10.0 to the setLength method. How do I do that? I say box, which is pointing to the rectangle1 object, dot, and I qualify a call to setLength. Remember, setLength is the name of a method. So I am sending to setLength a value of 10.0. The 10.0 value that was passed as an argument will be referred to internally within the setLength method as len, and then that len will be assigned to length, which goes into this instance variable. Then it simply says execution is complete. Not very exciting because I'm not doing that much, but I have created the class. Now notice when I refer to rectangle1, there are no little red squiggly. I didn't need an import statement. It has resolved the reference to rectangle1, right? There's no red mark to indicate an error. The reason it was able to resolve the reference is because length demo and rectangle1 Java, they're both in the same package. If they're in the same package, then I don't need to do an import. Okay? So this has not been compiled. You see a little asterisk up here. So I'm going to do Control S to compile it. No errors. Of course, the asterisk goes away. So now I'm ready to run it. I go ahead and click the Run button to run the length demo. And it says it set the value, and it's done. Everything worked. So it resolved the reference. That's pretty exciting. Okay, so there's our first peek at creating a class of our own. And we're going to build on this and go a bit deeper. Let's continue with our discussion of writing our own class. Okay, we talked about object instantiation previously, and we had shown how the rectangle object was instantiated in our first example, our first pass at creating a rectangle. We simply said new, and then rectangle, and then the empty parentheses, because we did not explicitly define our own constructor, but we relied upon the constructor that was created for us by the Java compiler, the simple noarg constructor. But the concept is the same as to what's going to happen. The rectangle object will be instantiated. The member variables, storage will be allocated for them, and initial values will be assigned. The initial values we had no control over, other than by choosing double or float, we got 0.0, as opposed to choosing int, we would have simply had 0. So that was the extent of our control, based upon the data type we had specified. But later on, as we define our own constructor, we'll see we'll have much greater control over this. But again, the variable that we created here, called box, is a reference variable, and it contains effectively the address or a reference to wherever that chunk of storage was allocated in memory for the rectangle object. Now, we had created the setter to set the length. We can now create a getter or an accessor or inspector method to get the length. And again, this is going to provide the controlled access. We don't want applications or users going in directly and touching the inner workings of the objects we've instantiated. So when we say get length, this is going to return something because it's a getter. Remember, our set was a void. It didn't return anything. It accepted an argument and played with that. It assigned it to a value of a member variable. But here, we're not passing it anything to operate on, but it will return something. So this is not a void method. This will return the value of length. So now we have the set with and get with. Let's go back into our IDE and look at a variation of this program. Rectangle2 will be our new class, and we'll have an application called length with demo because we'll be using both of these attributes. So we'll take a peek at our environment. And what I'll do is I'll close this guy out. We won't need this for now. And we'll go ahead and within our package, we'll go ahead and create a new class. And the class is going to be called Rectangle2. And again, no main method because this is going to be an actual class, not an application. And there's our skeleton code. Now, I'm going to grab that code that I have already and I'm going to pop this in there. Okay, it looked like it copied okay. I don't see any errors indicated. And what we have is the rectangle class version 2 here, where we've got the private length and width once again, and we have our set length, but we also have set width because typically for each attribute we're going to have a setter, so externally code can send a message to assign a value. And for each attribute, typically we'll have a getter because externally, from outside the class, some code could send a request to inspect or examine the value. So in each case, we're returning a double, as those are the data types. Again, notice a little asterisk, it's not compiled. I'll hit Control S, compiles it, the asterisk goes away, and I don't get any errors, so the class looks good. What I'll do now is I'll take the application called, this was what, length with double, or I'm sorry, length with demo. Okay, so I'll take the code for length width demo, and I'm going to take this and create another class, but this one will be an application. So this is called length width demo. Because it's an application, we want to include the main method. Okay, and what we'll do is we'll get rid of this, replace it with what I copied, and that should do it. So again, a comment as to what this thing does, and we are instantiating a rectangle2 object, and again invoking its constructor, using box once again, and using box as the reference variable, we're qualifying calls to set width and set length, and assigning values, and then down here we're qualifying calls to get length and get width to retrieve and subsequently display those values. Let me go ahead and fire this up. And it tells us the box's length is 10.0 and the box's width is 20.0. And those were the messages that came out from down here. Okay, invoking the getters. Pretty straightforward, okay? But again, the reason there's no need for an import of this rectangle2 class is because rectangle2 and the application that uses it, both files are within the same package. So that's the importance of packages. Let me show you a little bit of a difference here. Let's suppose I wanted to create another package. So I'm going to go in here and I'm going to create another package and say File, New, Package. And what I'm going to do is call this the rectangle package. Now notice the package called rectangle package is in the same source and it's in the same project here as Introduction to Classes. And what I want to do is I want to take and create an object in here create a new class, and I'm going to call it rectangle2, and it will be a class. It doesn't have a main, it's not an application, and we have that guy down here now. Then what I'm going to do is go up here and take this code, and I'm going to grab all of this code except for the package statement. I'm going to go over here and drop this in. So now I'll compile this, and now I have this rectangle2.java, but it's in a different package, which means it's a different kind of namespace is technically what it is. And then I'm going to go back to this rectangle2.java, and what I'm going to do is remove it from the package, the class package. Now when I look at the length demo, I don't even have to do anything, and notice I'm getting these little red marks, these errors, wherever I'm making a reference to rectangle2 as a class or as its constructor. It can't find the thing. Okay, so it tells me as a quick fix, you need to import this thing. It's no longer available because it's in a separate namespace, kind of it's in a different building. So now I add an import, and this guy is called rectangle2, but notice where it is. It's in rectangle package. So I'm going to add an import statement up here. Import rectangle package dot rectangle2. And as soon as I do that, notice that the red squiggly, the error that was down here, goes away. I do the Control S. It compiles. Let's go ahead and run it. And it works just like before. But the point is that this Java class is not in the same building, it's not in the same directory, it's not in the same package as the application that uses it. But by putting the things in the same package, I eliminate the need for the import, because these things are going to be used together, so they're stored together. Kind of a very interesting but subtle point to be aware of. Now when I put the rectangle class in a separate package, I have to import it to make it accessible. Keep that in mind, very important concept. Okay, let's get back into our show. And we've got one more method to talk about, and that's the getArea. The getArea method returns the area, computed area of a rectangle object. What's interesting is the getArea is going to be designed such that it operates on the length and the width member variables, but these values are not passed in as arguments to getArea. They are automatically available to getArea because getArea is a method within the class of rectangle. Therefore, it has access to the member variables. It has access to the length. It has access to the width, and simply makes direct reference to them and does the multiplication and returns the result of the multiplication, the product of the length and the width. There was no need to pass them in. They are automatically made available because they are part of the class, and the method called getArea, that function, is part of the class as well. Okay, the code for this is in rectangle3.java and rectangledemo.java. I'm not going to go through this, but I would strongly encourage you to try these out doing exactly what we were just doing. Now, the concepts that we've been looking at are very important. The concept of what's called data hiding says that the fields within the class, and hence within the objects that are instantiated from the class, are deemed to be private. They have an access specifier or visibility modifier of private, so they cannot be directly touched or looked at by gaining access to the object itself. You must go through the methods, the accessor and mutator methods, which provide what we're calling controlled access to these member variables. The methods that are accessible to us have all been defined as having public access. Hence, they constitute what's called the interface to the object. That's how we interact with this object, by going through those things that we can see that are public and hence made visible to us. Okay, so an object hides its internal private fields from code outside of the class. That's the class in which it lives, from which it's been instantiated. So only the methods defined within the class that are deemed to be public are accessible to code outside the class, and that's how we gain access to what's going on inside the class. The reason this is so important is discussed down here. Data hiding is important because classes are typically used as components in large software systems. In an academic setting, you write a program, you write a class, you're the author of the class, you're the author of the application that uses the class. It's hard to see the importance of data hiding. But in reality, what will happen is different users will be dedicated to writing the classes that may be accessed by code in applications written by different people, other people, not the same people who create the class. And we have to be assured that things are going to be done in a consistent, coherent manner. So data hiding effectively helps to enforce the integrity of the internal data, the internal structure, the internal state of the objects. Very, very important concept. Now, there's another thing to look at. When we did the area, we computed it. So immediately we said, okay, get the length, get the width, and then do the multiplication. why didn't we pre-compute this? Why didn't we compute the length and the width in advance? Well, there's a concept here of this is what's called derived data. So some data is the result of a calculation, that is, it's derived when needed, on demand. So length times width is what we did. We derived the area, the product of the length and the width, as needed. That's what area is. If we had pre-calculated this, it's possible that over time this rectangle might evolve. Suppose this rectangle represented a building. Maybe it was your home. And being your home, your house, you decided that, oh, there's just not enough room in here, so we're going to knock down this wall and extend this by another 12 feet, add another building. Oh, I'm sorry, add another room to the building. So that means the original rectangle that defines or describes the house, its length has now changed. So because the attributes or member variables are potentially dynamic and subject to change over time, that means that the stored value that we would have computed for length times width would have become outdated. It would have become what we call stale. So if we have attributes whose values are subject to change over time, then we don't want to use those and derive values and store the derived values because they could become outdated or stale. So therefore, if it's something that is subject to change, we compute it on demand or derive it only when needed, rather than store it in such a situation where it could become stale or outdated. Very important concept as well. Maybe the example with rectangle is not the best to stress that point, but it does get across the idea that the values could become outdated or stale. It's something we have to consider when we design the classes and decide upon which methods to create and how to define those methods, and also which attributes to create and whether they should be derived values or not. Okay, so fields and methods that are declared as we've illustrated up to this point are referred to as instance fields or instance methods because they are part of the object. Each object is an instance of the class, and each object will have its own length, its own width. We could have a bunch of rectangles out there. For example, if the rectangles represent different rooms, then we could create a rectangle which represents the kitchen in the house. We could create a rectangle which represents a bedroom in the house. We could create a rectangle which represents the den in the house. And presumably, each of these rooms, hence each of these rectangles, would have different dimensions. They would not all be exactly the same. Therefore, we're using the concept of rectangle as a general notion, and then the instances are going to be specific and unique in some way. So there's an application out there called roomareas.java that will illustrate this, and I encourage you to take a look at that and explore that code as well. Now, the other thing we've talked about was constructors, but we didn't really talk about how to make a constructor. We have one automatically created for us, which is a no-arg constructor, which is convenient, but the idea is sometimes in the constructor, we might like to actually execute some instructions ourselves. Remember, the constructor will be executed when the object is instantiated. When you say new and put the name of the constructor, the name of the class, what will happen is storage is allocated for an object of that class, and the instance or member variables are created and initialized. What we might like to do is not just use 0, but use some other values. For example, suppose the values we were going to use turned out to be integers that, if we don't initialize them ourselves, would be initialized to 0. And suppose one of the operations that we wish to perform is going to be to divide by one of those instance variables. And if we just let the system initialize without any other preparation, we would attempt to divide by something that has 0, and divide by 0 is not a good thing. Okay, we would have an exception that's thrown. So therefore, we talk about creating what's called a safe state. For example, if one of the integers was going to be something that would end up being a divisor in some capacity, then we don't want it to be set to 0 ever. So especially initially, when we first start off, we can't say, don't use the division operation until you've done such and such. We can't really cause that to happen. I mean, you tell people to do it, and immediately what are they going to do? They're going to do it before they perform the prerequisite operation. So you know they're not going to listen. So somebody's going to try it out. So what we're going to do here is establish a safe state. And what that means is by writing our own constructor, instead of taking the default initialization values, we're going to control what the initial value is for the variable. So constructors have special properties that set them apart from other functions. A constructor is sometimes called a method. I think technically it really isn't a method, and object-oriented purists will go out there and say, no, it's not a method, and they'll dispute the point with you. So I'm just going to call it a function. Okay, so the constructor is a function, but what's different about the constructor versus other functions is the constructors have the same name as the class. Constructors do not have a return type. Doesn't mean they're void. They don't even say void. They return nothing. They don't even specify void. That's a big distinction. Constructors may not return any values, and constructors are typically public because you want to be able to invoke them and instantiate object. So those are important characteristics of a constructor. So here's an example of a constructor for our rectangle class that we've been working on. The constructor accepts values for the length and width. Remember, there's a no-arg constructor created for us automatically, but we're going to create our own. And our own will accept a double, which represents the length, and a double, which represents the width. And what we're going to do is assign those values passed to the constructor to the respective instance variable. See, the constructor will be fired up automatically once the new operator says, invoke the constructor. What it's doing is it's allocating storage for the object and the variables of length and width in this case, and then the constructor will get a chance to execute, and it's only upon completion of the constructor's execution that we will actually receive the address in our reference variable to gain access to the instantiated object. So the sequence of events is pretty important here to recognize. Okay, so when an object is constructed, the constructor is always invoked. And if you don't write a constructor, we get one for free from Java, but it doesn't do much, okay? So that default constructor is also called the no-arg constructor. What it does is it sets the numeric fields to 0, it sets Boolean fields to false, standard initialization for the primitive types, and it sets object reference variables to the special value of null. That is, if there are references within an object to other objects, they are initialized as null pointers. And we'll talk about composition and aggregation later on to address that point. So the default constructor, as we said, is a no-arg constructor. If you go back to rectangle1.java, we didn't have anything ourselves to work with, so we use the no-arg constructor. But rectangle 4, the last version that I have out there, we'll see is going to include a user-defined constructor. And this is actually pretty neat. We'll take a look at it. So what does it do? Well, you can have a no-arg constructor that you write, and this is where the benefit is we get a safe state. Remember, we had a constructor called rectangle, and we didn't pass it anything. That was the one that we got for free. And the one for free, what it did is it initialized length and width to 0. But here, the one that we're writing replaces the free one. It's a no-arg, but we explicitly assign 1 for the length and 1 for the width. That way, we're guaranteed to say we've got a safe state. We know that if the length has to be something greater than 0 and the width has to be something greater than 0, that we're going to start off right out of the box with a rectangle whose attributes have been initialized to something other than 0. So that's why we would create our own noarg constructor. But we can also create another version of the constructor that would accept from the user a length and a width when the constructor is invoked, hence when the object is instantiated. This is a concept of what's called overloading. We'll have multiple versions of a function. Here we'll have two versions of the constructor, one that accepts no arguments and one that accepts a value for a length and a value for a width, two double values. So what happens is the signature of these two will be different. They'll have the same name, both the noarg and the constructor that has parameters passed to it. They'll have the same name of, say, rectangle, but their parameter lists are different, hence the signatures, kind of the first line, the heading, will look different. So the way I call the noarg is simply use the name of the constructor and then parentheses with nothing in it. When I call the other one, I use the same name because the function is the same name, but within parentheses, I pass two double values, one for length, one for width. Based on that, the runtime environment is able to ascertain which version is appropriate to run at a particular point in time. So when you have overloading, you have multiple instances of a method with the same name, but their signatures are different. They accept different parameters. And because they accept different parameters, the system is able to figure out which one to actually invoke. Now, because you're calling something with the same name as something else that has that name, the system has to match them up in some way. The process by which the system matches up your call to the correct piece of code to execute, the correct version of the method, is called binding. So it looks at what you've passed for arguments and it said, well, this is the one that agrees with it. So it says this is the one that will execute. That process of making that decision is called binding. So overloading applies to constructors, but later on we'll see that you can have two other methods that have the same name but different signatures. They can also be overloaded. So methods and constructors can be overloaded. So in overloading the constructor, this is what we would get. We would say rectangle with just parentheses, that's invoking the noarg version. Rectangle with 5.0 and 10.0, that's invoking the version that accepts two double arguments or two double parameters. Let's go ahead and take a quick look at this. I'll get rid of these guys. And here's the code. Okay, so what I've got is Rectangle 4, the latest and greatest version of Rectangle. Keeps getting better. It's like watching the old Rocky movies, right? Rocky 1, Rocky 2, Rocky 3. We're up to Rectangle 4, okay? So what we've got is we've got our two attributes. And here's a constructor. This is the one that takes the two arguments. Likewise, I could create a second one, as shown in the handout, where it accepts no arguments. So for example, I could go ahead and modify this. So I could take this guy here and say, let's go ahead and rectangle 4 and take nothing. And what I'll do is I'll put, as I did in the handout, 1.0 as the values. So now I have two versions of the constructor. It's an overloaded constructor. And that's perfectly valid to do that. Then I've got my setter for the length, my setter for the width, my getter for the length, my getter for the width, and then the computation of area. And at this point, it's a pretty complex little class from where we started. So that's the basic idea then on creating classes and instantiating objects from them. So there's a lot of neat stuff there. And this is only the start, because we really want to look at things like overloading in some detail, overriding. We want to look at inheritance, and we want to look at polymorphism, all these other neat things that happen when you start to deal with classes. But this is enough to get you going with classes. I threw a lot at you. There are several examples. Probably take a little bit of time to absorb all of this and reflect upon it, but hopefully it makes sense. Really, what we've gone through so far is really not that overwhelming. So anyway, I hope the video was informative and helpful, and if you have any comments, just leave them in the comments section and let me know. And once again, thanks for watching.